So on this graph, this is the same motion as on the previous video and the previous question that we did. Both of these graphs, all three of these lines show the same motion, exactly the same motion. Have a think about what that might mean. Why I can say that each of these colored lines represents the exact same motion. Should I really think about that for a minute? What if I told you that the blue line here represented distance, the red line represented displacement, and the green line represents the total distance traveled? Okay, so all three are the same from, I'm going to call this point A to point B. All right, they're all, so I've gone in one direction at one velocity. So the total distance traveled is the same as the distance away from home. It's the same displacement from home. Okay, from the origin, from our starting point. At that point, our graphs diverge. Now, distance and displacement, our distance and displacement, the distance is telling us the total distance we are away from where we started. So that's going to reduce. And the displacement tells us where we are in relation to where we started with a positive direction. So that's going to reduce as well. But we're still traveling. So our total distance traveled is going to increase. And in fact, it's an interesting thing that we reach the point C here. The total distance traveled continues to increase at the same rate once we reach C. That's because it's at C where we get back to our starting position. But then we go beyond our starting position. So our displacement then becomes negative. So we're now the other side of our starting position. However, our distance away from our starting position, if that's not really a vector, our distance is just telling us how far away from our start we are, we then become a positive distance away from where we started. Here we become a negative displacement away from where we started. So imagine I was 1 meter behind the start line. I would still be a distance of 1 meter away from that start line, but my displacement would be -1. And my total distance traveled would have been the total distance I've gone forwards and the total distance I've gone backwards. But notice the gradients of these lines. I know that the gradients are negative for the distance and displacement between B and C, and positive for the distance traveled between B and C. But they're all to do with 1 and -1. And when you get to point C, displacement being negative, the distance then becoming positive, that positive gradient for the distance is still the same as the positive displacement for the distance, positive distance traveled. And notice that line, even though there seems to be a break at C, in fact, it's still one part of a journey. So B to C to D is all one part of a journey. B to D is a constant velocity of 1, in this case, 1 unit. Because our change in Y is 3 units, our change in X is 3 units. So our velocity, 3 divided by 3, is 1. And it's a constant velocity. That velocity doesn't change once we reach our start point. It carries on. It's just our distance and our displacement diverge. At that point, to get from D to E, then we are stationary. Okay, so no velocity at all. The displacement, the distance, and the distance traveled all remain the same, so we're not moving at all. And finally, from E to F, well, yes, we've reached home again, our starting position. E to F along our displacement is going in the positive direction because you're going from behind the start towards the start. Our distance is going in the negative direction because we're going from 1 meter away from our start to where we started in the first place. So our total distance becomes 0, and our distance traveled increases by that 1, just like our displacement, because we have traveled a further 1 unit. So it's a really interesting way of representing a journey, is this. The fact that there's a total distance, there's a total displacement, and there's a total distance travelled altogether. And you've got to understand the difference between each of those three